mentioned. So here's a healthy cell. This is what your face looks like at a cellular level. And so the natural killer cell sees this and says, oh, that's Charlie. I know Charlie. You know, he lives down the street. He's a good guy, has the hardware store. Little kid fell off the bicycle last week and his oldest son just got married. He knows everything about you because these cells, every day they're circulating throughout your body, visiting each cell in that community. You know exactly what's going on. It's a small town. This cell here, the Pablo Escobar cell, it's transformed. It looks different. Okay? It doesn't have your face anymore. And so this natural killer cell binds to it and injects those granules that I mentioned. And so at the end, even though it has less of these granules, which you could say are kind of like bullets, it has dissolved this cell. And that's really important because you don't want to just break the cell. Because if it's infected with a virus, it just releases more virus particles. You want to dissolve all of those things that are in the cell. Because the DNA, for instance, of a cancer cell has the code, the abnormal code, to create more cancer cells. You don't want that DNA floating around. You chop it up into little pieces that the body can use as nutrients because every enzyme that might be in the cancer cell is now broken down into smaller parts like amino acids and so on. And so this is important. And if you look at this, then the analogy that I was talking about, you know, this is the kid from the small town. And I mentioned the transformed cell, that what happens is through some sort of error in the DNA, the multiplication of the cell, duplication of the cell DNA, being hit by UV radiation, gamma radiation, lots of different things, emotional factors, this cell can start to express itself differently. And that is that cancer cell, or if it's infected by viruses, it ends up having the same effect. And again, referring back to the study, the concepts of HIV from Greece, it's actually very important because attitude, as I'll mention later if I have that much time, is an important factor because the immune system is just a circulating component of the brain. It has the same receptors for the same neurohormones, the same messenger chemicals in the body. As soon as you get depressed, your immune system gets depressed. As soon as you get happy, your immune system gets happy. When you get frightened, your immune system goes on alert. Now, your immune system, when you get frightened, it thinks that there is a tiger chasing after you because that's what our program is, because that's our recent history. It doesn't realize that it's a state patrol police officer chasing after you because for driving too fast. Okay? It doesn't realize that it's your ex-wife chasing after you to get an alimony payment. It thinks that your life is at stake. Okay? And so it has that same response. And so when you live in that chronic stress situation, where on a day-to-day basis, perhaps because you don't like your job and you don't feel like getting up early and you get stuck in traffic, and so you're chronically 10 or 15 minutes late, and you always feel bad about being 10 or 15 minutes late, and you walk in and you're hoping no one sees you, and you want to get in your desk and open up the computer and look like you've been there for 20 minutes. And anyone who comes in and says, oh, Charlie, there you are, you think, did they come by 5 minutes ago and realize I wasn't here? And you have that response, just like you have that response when the siren goes by because you're going 5 kilometers, 10 kilometers an hour over the speed limit. All that response all the time is like tiger, tiger, lion, tiger, all the time. Okay, and the body is constantly responding to this threat. We're not designed for that. Tigers either eat you or they don't. Once they've eaten, they go away. There's no way that you're going to live in a little village in Kenya or wherever else you might be in ancient France or someplace being a Neanderthal, and there's a mountain lion waiting for you every morning on your way to work. It doesn't happen that way. They eat and they move on. But we've created a lifestyle in which we have these constant threats that our body is interpreting as life or death because we think of it that way. So you can see how important that emotional component is because it's like, oh, if I get one more speeding ticket, I lose my license, I can't drive to work. And so that feels like survival. We interpret it that way. So this aspect here, this transformed cell, even beyond those emotional factors, the analogy I use for that sometimes is like if you have a kid from a small town, a small farm town, and for the summer, he goes to visit his cousin for 3 months that lives in the Bronx in New York. And while he's with his cousin, he changes because he's part of that different community. So he gets everything pierced and tattooed and starts wearing clothes that all hang off, and they're all black clothes, and he's walking like this, and he's got a hat on like this, and he's listening to hip-hop music instead of folk music, okay? And by the time he gets back home to the small town at the end of the summer, he looks completely different. He doesn't look like he belongs in that community anymore. The natural killer cell identifies him right away because he's transformed. He's become different. If he's not harmful, then it's not a problem. That's just called a beneficial change or a mutation. But I must have gone over time. Mysterious forces are at work. And so that's that process. That's a way of understanding cancer and understanding what occurs and how the immune system is functioning. So while we're waiting for this to come up, does anybody have any questions on that part?
Can you just say what you said before? The immune system is a circulating
component of the brain. So this next set of slides basically is just to show you that, oh, there we go. Natural killer cell cancer therapy is a major objective, current project direction in cancer research, in drug research, in drug companies. They're looking for a drug that is BioBran, that's non-toxic or limited toxicity, since they're accustomed to lots of toxicity, that's not as big of a deal, but that stimulates the immune system, that stimulates natural killer cells to be more active in eliminating cancer. Because finally people have come around to realizing, oh, you don't cure cancer with toxic drugs that kill the cancer. What's the basic theory of cancer chemotherapy, of any kind of chemotherapy, but specifically cancer chemotherapy? It's very archaic, it's very barbaric. It's like something from the Middle Ages, you know, like from a witch hunt. Because what are you doing? You're giving a person poison, and you're hoping the cancer dies before the person does. And if not, you say, well, they would have died anyway. It's like with the old witch trials where they would tie the woman to the chair and throw her in the water, and if she sank, that meant she was a human, and that meant, well, you know, she's with God now, and if she floated, then you killed her. So it was, you know, it's that same sort of mentality. And chemotherapeutic agents actually cover a wide range of drugs. In the traditional definition of what chemotherapy is in pharmacology, it's not just for cancer. Antibiotics are chemotherapeutic agents. All of those are chemotherapeutic agents. So anything, because what they are is they work against life. That's what antibiotic means. Okay, it's working against the life of a bacterium, working against the life of fungi. We don't really have them for viral diseases, even though they say you do. Whatever the name of that drug is from Holland or whatever, it doesn't work. But that's another story. Against parasites, against cancer. So these are different levels: bacteria, okay, fungi, parasites, cancer, which are human cells. All of those drugs that we use to defeat those infections or cancer are all called chemotherapeutic agents. As you move down through that list, from say an antibiotic like penicillin, not particularly toxic. As long as you don't take it too much or for too little, you know, it's okay. It might disturb your bowel flora, but again, like I said, you can eat yogurt or whatever. You can reestablish that. It's not so toxic. Why? Because it's directed against bacteria. It's designed to disrupt the formation of bacterial cell walls so that they leak, so that the bacteria die. And human cells don't have cell walls. So the target for that drug is not really affecting humans, most of us, okay? And so it doesn't make you sick in general. You take that next step down to fungal cells, you've gotten closer to cells that are like human cells. Now, we don't think of fungi as being like us, but at that molecular level, they become more similar. The enzyme that this antibiotic is supposed to interfere with is more similar to the human enzyme. And so at the same time that you're killing this fungus, you're weakening the body at the same time. And you might have a symptom like nausea or vomiting or those sorts of things. The next step down with parasites, okay? Antifungal drugs are known in medicine to be horrendous drugs when you give them to people. People get very, very sick, okay? You hate to see people have to take those drugs, okay? Anti-parasitic drugs, again, parasites are that much closer to us. And so whatever poisons them puts us even at more risk. By the time you get to a cancer cell, that cancer cell is human. Not only is it human, it's you. It's that cancer patient, it's their own cell. How are you going to kill that cell or make it sick and not make the rest of the person sick. It's only logical that it would happen that way. And that's what that problem is. You have this weapon that's just randomly directed at killing cells. And it just happens to kill the fastest growing cells faster. Okay, so it kills teenagers before it kills old people, kind of a thing. Because teenagers are growing faster. Okay, and so that's really the basis of it, saying, well, hopefully your tumor is growing a lot faster than you are and your tumor will die. That's why people have diarrhea and vomiting and their hair falls out and their skin gets bad, because those are the fastest growing cells in the body. The hair, the skin, as I mentioned, the skin is also part of the digestive tract, okay? And so those are affected because they're rapidly dividing all the time. Most people, it doesn't affect their brains because we don't use our brains that much, and so the cells don't divide that much because most people aren't thinking, they're just kind of watching television, okay? And so it makes the brain very safe in one sense. And so here, this is from a paper from 2006, that natural killer cells are important players, first line of defense against diseases. Cancer cells, it's a natural response from natural killer cell cytotoxicity. The cytolytic action of natural killer cells is characterized, and this time it actually worked quickly. Anyway, but it's characterized by cell surface markers, as I mentioned, that they look for that difference in the face. Strategies are being pursued to apply natural killer cells as therapeutic agents against a broad range of malignancies. Remarkable results, including survival improvements and amelioration of graft versus host disease. That's when you give people transplants and also sometimes bone marrow transplants for leukemias. Those remarkable results have been obtained with what are called alloreactive natural killer cells in some cases, and I won't go into the details of what that means. But clinical application of ex vivo manipulated cells, which are natural killer cells, for example, that have been taken out of the body and treated with an agent so they become kind of more hyper, and then go back in to fight against the cancer in the body. And that actually has a term already that's called adoptive immunotherapy. This is just a diagram from that article, but looking at this strategy of aiming natural killer cells, activating natural killer cells against cancers in the body, myeloma, B precursor leukemia, epithelial tumors, breast cancer, ovarian cancer, squamous cell carcinoma, which can be the lung and skin. It improves cytolytic efficiency and has accessibility to resistant tumors. These are all the functions that we have already in BioBran. So here, these are just some articles that I grabbed even from the internet. This one's from Italy, and this physician here, professor actually, they have so many problems with toxicity and bone marrow transplant issues, and how he had a grant from some foundation here to look at how you can harness the qualities of natural killer cells without raising the risk of graft versus host disease, meaning that if you get natural killer cells from someone else, you might have a reaction because they come from someone else. And he came up with the idea to have donors from the patient's own family who are at least a partial match, and then give those people an influx of natural killer cells, and that he found in some cases that these natural killer cells were active in the donor's bone marrow after transplantation, which meant that they were continuing to propagate and grow, and so therefore they could launch an effective attack on leukemia cells, and he could predict in advance using tests how effective that would be. And however, this mentions that some people, anyway, I'll just move on to this part, that it significantly increased survival anywhere from 2 to 30% among those patients whose disease had not fully responded to treatment prior to the transplant. Okay? And again, even with this, from inside the university, he's only allowed to work with the patients that are already end stage. He's not allowed to work with the fresh people that just came into the clinic that haven't been tried on any drug, because like I mentioned, that's just the way people are. They're skeptical, they like to maintain control and confidence and all those sorts of aspects. And so for patients considered ineligible because of chemo-resistant leukemia, this is a potentially life-saving advancement. It's not a prejudice against natural medicine, it's just the nature of the fearfulness, if you will, the standard of, as you call, classically trained physicians and PhDs. But he says it's likely to make enormous changes in the practice of transplantation worldwide What they're talking about here is the standard activity that we see with BioBran that's been studied over the last 10 or 15 years. Cancer researcher from the National Institutes of Health of the United States, article from 2006 of last year, and researchers from the National Institutes of Health are fighting cancer by using the immune system to attack tumors, okay? And they've used viruses to introduce new genes into cells to make them into cancer-fighting cells. Now see, for me, that's not good news, that's scary news, because every time you work with a virus, you know, it's kind of like anything else that a human does. You know, there's quality control. And there's some things that turn out really well, and there's other things that don't turn out well at all. It's like if you buy a dozen eggs, maybe they're all good. If you buy 100 dozen eggs, you find a lot of really ugly eggs in there, okay? And when you use viruses to introduce new genes, you don't really know what it's going to do, okay? But the thing is, with cancer, people are dying, and so sometimes, you know, caution is thrown to the wind, and we think, well, as long as we help a few people, then it's okay. You don't find out for 30 years it causes some sort of weird effect. Like, you know, it's been found with other drugs like thalidomide and all of that, which is still used, actually, thalidomide. Here, again, how natural killer cells are being put to work or rest in destroying cancer cells. And actually, this work here, the research, Michael Caligiuri from Ohio State University, he was actually at Stanford when I was there. Interestingly enough, in the article they mentioned only about a third of the women who take this monoclonal antibody that is designed to work in combination with chemotherapy. You see the theme, the thread, that dramatically improves disease-free and overall survival in women with breast tumors that overexpress a particular protein. That's a little small population. It's not working on all cancers, it's just breast, and just a specific class of breast cancer. But even in those people from that little group, only about a third of the women that take this drug receive benefit from it, yet they're very excited about it because, as I said, in general, medicine has no clue what to do with cancer. Even though they might stick their chest out and tell you not to use your product, their products don't work, okay? Attempts to improve its efficacy, increase safety, and understand the resistance that some patients have has been slow. Why? Because researchers don't exactly know how the drug works. Has anybody ever said that to you? Well, how does that BioBran stuff work? And that herbal, you know, homeopathic stuff, how do you know it works? Who knows how it works? They don't know how theirs works either. And so I had the idea when I read it, I said, that must be why they call it a wonder drug. It's like, oh, I wonder how it works. I don't know. So, but this is the nature of medicine, okay? This is where the standard is. It's not like they have the answers and we don't, okay? You need to develop that level of confidence in your product that it's not still in the stage of being proven. It's been proven. It's proven in this context of natural killer cell activity. Again, I'm not talking about cancer. I'm not saying it cures cancer. It does this. It has this specific activity of natural killer cell enhancement. And the literature of science says, hey, if you can improve the activity of natural killer cells, because they're the first line of defense against cancer and viruses, that can really improve your health and improve your chances of surviving cancer, improve your chances of, you know, living well or living better with cancer, with HIV, with hepatitis, perhaps turning the disease around, okay? That's what the science says. I don't need to say it, I can just refer to what they've said. I look at the studies we've done and the studies they've done and just put them together and see what does it all say. So this is something I've kind of already gone into, but that your body has innate cellular special forces that can eliminate cancer before it ever takes root. And this is the famous picture that everybody has a copy of. And it's like a tireless and conscientious gardener eliminating weeds before they grow. And I use that as another analogy, again, recognizing this community of cells that is your body. We think of it as our body. It belongs to us, we put clothes on it, we buy a house for it, it's ours. You know, we pay taxes on it, all those things, okay? But how does a mosquito see our body? You know, how, again, like I said, a mountain lion, it sees it as food, okay? How do bacteria see your body? It sees it as a new neighborhood, place to set up house and grow a family, okay? And the reason I use the example of a gardener, for those of you who may have gardened or observed gardens, when you clear out an area, say near your house, and you decide to make a garden, and what do? You take out all the stones and everything that's growing there, and you put the best nutrients in it, and you till the soil, and you put peat moss and whatever fertilizer and all those things in there, and then you put your chosen seeds in there. Carrots, kale, Swiss chard, cabbage, whatever it might be, potatoes, and you hope that they grow. Now, if you walk away like me and go on a business trip for 6 weeks and come back, how many potatoes and carrots and kale, and what's going to be growing there? Will it just be the things that you planted? No. Everything in the universe has shown up at that garden because it's an opportunity to live, just like for any of us. And so the dandelions and the thistles and all the things we don't know names for are all showing up, and they've put their seed in too. And if I only look at my garden every 6 weeks, it's likely going to be taken over by those weeds instead of the plants that I'm growing. Why? Because the plants I'm growing are friendly, cooperative parts of the community. The weeds are aggressive, like cancer cells are. Okay. And so the way you keep your garden pristine is that each morning, maybe even twice a day, you go out and you take a look at the garden and you see the carrots are coming up a little bit, and there's a little garlic growing up, and the potatoes and the red chard, and oh, what's that? I didn't plant that, it's not even in my line of rows, and you pop it out. And there's another one here, and there's a little dandelion, and you pull out 4 or 5 little seedlings. And you come back the next day, and it's like, oh, there's another one, lots of dandelions are growing. Good thing I'm doing this every day, and I'm not gone for 6 months, 6 weeks, okay? That's what the natural killer cells do. They're constantly circulating and moving around and identifying, because it knows the difference between carrots and celery and squash and potatoes as opposed to thistles and dandelions and grass and things that have started to grow. That is the process. It's a natural process just like any other. Hopefully that's helped you to understand how the immune system works. Here are just some pictures of some immune cells in the bloodstream. These are red blood cells, these red discs. And these are T lymphocytes here in green. These are macrophages, which also are activated by Bran. And this is from a leg wound. Again, trauma, the body responding to trauma, because if there's a puncture wound or a break in the outer line of defense, which is the skin, the most important part of the immune system really is the skin, then the body immediately responds because it expects some sort of infectious agent to be looking to set its seed down in your garden. And so it goes there immediately to identify what may have found its way in and eliminate it. This is a picture of my parents on their wedding day. And we've had a lot of mention here about cancer survivors. This is my mother here from around by that same time. I would like to suggest to you that all of us are cancer survivors, okay? On 2 bases. For instance, for me, one, I'm a cancer survivor because my mother died of cancer when I was 11 years old. Cancer is not a disease that affects individuals. It affects everyone who cares about that individual. It's a disease that lasts a long time, and you watch the person slowly go through demise and a degraded lifestyle. They're in pain, they can't eat, and they lose all human dignity and often the ability to function as a human. I mean, just even simple functions like to be able to sit up in bed and watch television or read a book. That has an immense effect on a family, on a husband or a wife or on children, okay? And that effect is a serious effect. You might say, oh, well, it's social, it's part of life, it's all those things. Well, if you want to look at it from a medical standpoint, a study recently showed that the partners, gay men who had a partner who died of AIDS, they showed immune suppression following that death, okay? You know, often you see someone who's elderly and their spouse dies and then they die 6 months later, okay? That same process is in effect. So that's a serious effect. It's not just something to disregard. But also, in the other aspect, how else am I a cancer survivor? And of course, there's BioBran. I don't take this version. I take the Peak Immune 4, but if somebody gave me a bottle, I would take it, or a pack. But I'm a cancer survivor like all of us are, because as I told you, on each and every day, we each develop 3,000, 10,000 cancer cells. They're always there. It's just part of normal life. it's not a bad thing. It's like every breath you take in, there's bacteria, okay? But you don't come down with influenza or with pneumonia every day because of the immune system. Because of an optimal immune system, perhaps those 3,000 or 10,000 cells are all eliminated. With a suboptimal immune system, you know, it's just a flip of the coin. So I'm sure I'm beyond time already here, so I'll probably just stop right here. There's a lot more stuff, but you know, this is a good stopping point. So I appreciate you. I don't know how long I went over time, but thank you.